So finding limits of functions numerical approach. Evaluate the limit of f of x as x approaches a by investigating the behavior of the function f near x equals a numerically. Number one, f of x is equal to x squared plus 2x minus 3 all over x minus 1 near x equals 1. So we want to find the limit of this function as x approaches 1. So that is what we want. Okay, guys? So, but we want it numerically. So we want to find limit as x approaches 1 of f of x. Our f of x is x squared plus 2x minus 3 all over x minus 1. Okay? Now let's see if the function involved here, this rational function, can still be simplified. Let's see. If the numerator can be factored such that it contains x minus 1, then we can simplify this, no? This rational function. So we have what? X squared plus 2x minus 3 all over x minus 1 is equal to x minus 1. Or what is the other factor, guys? Is it x plus 3? Okay, all over x minus 1. Okay, so we can cancel out x minus 1, no? So we are allowed to cancel this. After all, we do not want x equals 1. What we want only near x equals 1. So that's what we want. That's what we are going to investigate. Okay? So this will give us what, guys? X plus 3, no? But with the condition that x is not equal to 1. Okay? Is that clear, guys? So it means this function, x squared plus 2x minus 3 all over x minus 1, is the same with x plus 3 as long as x is not equal to 1. So it's better to work with x plus 3 in computations later rather than in this quotient form. Okay? So let's start. We're going to assign values to x that is first to the left of 1, but close to 1. So for x values, we have, let's say, beginning with 0.8. Then we have 0.9. And then 0.999. I mean 0.99. Then 0.999. Let's have up to 0.9999 and so on, no? And let's see what we will get, no? As the values get closer to 1. Okay? Now, what are the corresponding values of f with these values of x? So if x is 0.8, so plug in here. So rather than in this rational function, so we have 0.8 plus 3, so that is 3.8, no? Am I right, guys? You can also substitute here, but easier to compute in x plus 3 rather than in this quotient. After all, we are not going to assign 1. Okay, guys? So if x is 0.9, so we have 3.9. Okay? When x is 0.99, we get 3.99 for the value of f of x. So what is f of 0.999? So we have 3.999, no? And then if x is 0.9999, the value of f of x is 3.9999. So as you can see from these values, I think there is already a pattern, no? Okay, guys? So, and now we can conjecture, or we can say that as x gets closer and closer to 1, where do you think the values of f of x get close to, guys?
4.
4, no? So that means the limit of f of x, our f of x is this rational function, as x approaches 1 from the left, so meaning from the left of 1, is equal to what? 4, based on this observation. Huh? Okay, guys? What about for x greater than 1, but close to 1? So let us assign values of x. So let's start with 1.2. So we have 1.2. Then we have 1.1, 1.01, 1.001, 1.0001, and then getting closer to 1. So let's see how f will behave, no? So when x is 1.2, the corresponding value for the function, we have 1.2 plus 3, 4.2, no? And then when x is 1.1, 4.1. When x is 1.01, f of x is 4.01. If x is 1.001, f of x is 4.001. Am I right, guys? And then if x is 1.0001, f of x is 4.0001. So there's now a pattern, no? So the value is what? Getting closer to what? To 4 also, no? So from this behavior, we say that the limit of f of x as x approaches 1 from the right is equal to 4 also. So finally, we can now conclude that the limit of f of x, what is our f of x? X squared plus 2x minus 3 all over x minus 1. As x gets closer and closer to 1 is equal to what, guys? 4. Okay? Since both the limit from the left of 1 and from the right of 1, so the limit is also 4, no? So from the left and from the right, the limits are equal. So we say that the limit of x squared plus 2x minus 3 all over x minus 1 as x approaches 1 is equal to 4. Okay, guys? Is that clear, children?
Yes po.
Okay, so let's have number 2. What if we're given this function, no? F of x is equal to 1 over x minus 3 quantity squared near x equals 3. So this is what we want. Okay, guys? And we want to know the limit of what? Limit as x approaches 3 of 1 over x minus 3 quantity squared. Okay? So again, we're going to assign first values of x close to 3 but to the left of 3. So what are those sample values, no? That are close to 3 but to the left of 3? So let's say 2.8, no? 2.8. What else? 2.9. 2.99. We have 2.999. And then let's have the last one. And let's see if we can now find a pattern or enough values for f of x so that we can conclude what the value is being approached by f of x as x gets closer and closer to 3, no? From the left. So when x is 2.8, so what's the value, guys? Guys, what do you think? What's the value? Is it 25, guys?
Yes
Is it
po, sir.
okay? Guys, is it 25?
Yes po.
Yes po.
What about when x is 2.9? What do you think? Can you give
100
me
po.
100, sir.
100, no? When x is 2.99, it is, I think, 10 to the 4th. Okay? 10 to the 4th is what, guys? 10,000, no?
10,000.
And when x is 2.999, 10 to the 6. When x is 2.9999, we have 10 to the 8. Okay, guys? So what do you think is happening? How is f behaving? So it gets what? The function values get what? Get bigger and bigger, right? Guys? So it means it's going to be positive infinity. Am I right? So it means the limit of f of x as x gets closer and closer to 3 from the left is getting bigger and bigger positively. So meaning the function values keep on growing, no? Am I right? So that's how f of x behaves, no? When x gets closer and closer to 3 to the left of 3. What about if x is to the right of 3? So let's assign function values of x. So let's start with 3.2. Then we have 3.1, 3.01, 3.001, 3.0001. I think these are enough. So let's see if we can get a pattern. Okay. So what are the corresponding values of f of x? So for the first value, 3.2. So f of x is what, guys?
25, sir.
25. Also, no? What about when x is 3.5? I mean 3.1.
100 po.
100 also. And I think it is 10 to the fourth when x is 3.01, no? 10 to the 6 when x is 3.001. And then 10 to the 8 when x is 3.0001, no? So what's the trend, guys? The values keep on what? Growing also, no? Positively. So we say that the limit of f of x, our f of x is 1 over x minus 3 quantity squared, no? As x approaches 3 from the right is equal to positive infinity also. Now, this means that these limits do not actually exist, no? Because this positive infinity and then this another positive infinity here, they are not real numbers. Am I right? They don't exist also. But specifically, so it means it keeps growing, no? This one, it keeps growing also. So therefore, we say that the limit of 1 over x minus 3 quantity squared as x approaches 1 is equal to what, guys? As x approaches 3, I mean. Again, limit of 1 over x minus 3 quantity squared as x approaches 3 is equal to what, guys? Positive infinity.
Positive infinity.
Okay. So this limit does not exist, but specifically, the values of f of x keep growing as x gets closer and closer to 3. Okay, guys? So what about number 3? So given this f of x, which is equal to this piecewise function, if x is less than or equal to 0, we have the square root of 4 minus x. If x is greater than 0, we have x squared plus 2. We are interested with how f of x behaves when x is near x equals 0. So that is, we want to know the limit of f of x as x gets closer and closer to 0. Okay, guys? So let's begin with x less than 0. So for x and then corresponding values of f of x. So let's assign values. Let's say -1. Then -0.1. -0.01. -0.001. -0.0001. Let's say up to this, no? And let's see if we can now find a pattern. Going to be 0, no? When x is -1, what is f of x, guys? Is it 2.24? Am I right? We're going to use radical, right? This is square root of 4 minus x because we are assigning values to the left of 0. Am I right, guys? So 2.24 approximately. Then we have 2.02 when x is -0.1. When x is -0.01, we have what? 2.02. 0, 0, 2, I think. Okay? And then when x is negative 0.001, we have 2.0002. When x is negative 0.0001, we get f of x as 2.00002. Am I right? Or what do you notice with the decimal part? So it seems that it is what? Disappearing, no? So it's getting smaller and smaller, right? So that means as x gets closer to 0, f of x gets closer to what value, guys? What do you think? Guys? So 2, no? So we say that the limit of f of x as x approaches 0 from the left is equal to 2. Okay? So what about if x is to the right of 0? So let us assign values to x. Positive 1. Let's start with positive 1. And then 0.1. 0.01. Okay, 0.001. And then let's have this last one, 0.0001. Okay, guys? And then let's see what happens as it gets closer and closer to 0. When x is 1, we're going to use what? For f of x, x squared plus 2, right? When x is 1, we have 3. Am I correct, children? And then when x is 0.1, 2.01. No, guys? Am I right? When x is 0.01, we get 2.0001. 1, 2, 3, then 1. And then when x is 0.001, we have 2.000001. Am I right, guys?
Yes,
And
po, sir.
then when x is 0.0001, again, when x is 0.0001, we have 2.00000000, 1, 2, 3, 4, 5, 6, 7, then 1, no? So there's now a pattern, right? So the values of f of x get closer to 2 also, right? So we say that limit of f of x as x approaches 0 from the right is equal to positive 2. So we can now make a conjecture that the limit as x approaches 0 of f of x, this piecewise function, is equal to what, guys? Is equal to 2, right? So this is how f behaves near x equals 0. Okay? Any question, children? Okay, so let's have number 4 if you don't have question. For number 4, we want to know the limit of what? Of sine x over x as x approaches 0. Okay, so that's what we want. So let's start with values of x close to 0 but to the left. of 0. Assigning values to x, we have, let's start with negative 1. Then negative 0.5. Negative 0.1. Negative 0.1. Negative 0.01. Negative 0.01. Well, let's have these 4 values. If x is negative 1, by the way, if you have trigonometric, you are going to assign real numbers or radian measures. Okay, guys? So in calculus, we use radian measure or real number, no? If you have trigonometric. So when x is negative 1, sine of negative 1 over negative 1, that is equal to what, guys? Anyone? Would you please check? 0.8415 approximately. Is that correct, guys? Guys?
Yes po, sir.
What about when x is negative 0.5? 0.9589. Check my values, guys. And then when x is negative 0.1, we have 0.9983. 9983. When x is negative 0.01, we have 0.99998. Okay? What do you think is happening? As x gets closer to 0 from the left of 0, what is happening to the values of f of x, guys? What do you think? Getting closer to what, guys? 1, no? Because the trend is having many 9 values, no? 0.9999. Perhaps it will have more 9s, no? Up for the decimal part, okay? So we say that the limit as x approaches 0 from the left of sine x over x is equal to what? It is equal to 1, no? Guys? Am I right? So what about when x is greater than 0? So let's see how f of x will behave once we have values of x that get closer and closer to let's say, to 0, no? Okay. So assigning values, we have 1, let's start with 1, 0.5, 0.1, 0.01. I get here 0.8415 also, no? Like for negative 1 when it's negative 1. When x is 0.5, 0.9589. Okay? When x is 0.1, we have 0.9983. When x is 0.01, we have 0.99998. Okay? So same behavior, no? For f of x compared here to the first table. So going to be what, guys? This. As x gets closer and closer to 0, from the right of 0, the values of f of x gets closer and closer to 1, right? So limit of sine x over x as x approaches 0 is equal to 1. So we can now make a conjecture. So we say that the limit as x approaches 0 of sine x over x is equal to 1. Get it, guys? Let's have number 5. I think this is the last, so that we can proceed to algebraic approach of finding the limits. So we want to know the limit of e to the x minus 1 all over x as x approaches 0, no? So let's start with less than 0. Assigning values to x, we have, let's say, negative 1, negative 0.5, negative 0.1, negative 0.01, negative 0.001. Okay, so let's have at this moment up to this first, no? And let's just add another value of x once we don't get a pattern yet, no? So when x is negative 1, 0.63 approximately 0.63 to 12. When x is negative 0.5, we have, could you please check, guys, 0.78694. When x is 0.1, we have 0.95163. Okay, guys? What about when x is 0.01? 0.99502. Okay, guys? When x is negative 0.001, 0.99995. Let's have one more. Negative 0.0001. We have, what value do you think, guys? Guys, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Guys, I think I got a wrong value here. Guys, are you checking my values? 950 here. Let's add one more value of x. Negative 0.0001. So 0.99995. Okay? But there's no pattern, no? As x gets closer to 0 from the left, we have what, guys? Going to be 1, no? So limit as x approaches 0 from the left of e to the x minus 1 all over x is equal to 1. Okay? So what about when x is greater than 0? So let us list down values of x that we're going to assign. 1, 0.5, 0.1, 0.01, 0.001, 0.0001. Okay? So let's see. When x is 1, we have 1.7, 1.8, 2.8. Am I right, guys? Guys, still alive, guys? 1.29, 744. Okay, when x is 0.1, 1.05, 171. It's decreasing, no, and getting closer to 1, I think, no? When x is 0.01, 1.005, 02 approximately, no? So that's for f of x. When x is 0.001, we have 1.00050, okay? And then when x is 0.0001, we have 1. What's the value, guys? Guys, shift ln 1, I mean 0.0001 minus 1 divided by 0.001. So we get 1.000. What did you get, guys? Anyone? Guys? Guys?
1.0005 po.
So 1.0, how many zeros? 4, no?
Dapat po na 0.
Okay. So there's now a pattern, no? So it seems that the decimal part is disappearing or getting smaller, no? So as x approaches 0, f of x gets closer and closer to 1, right? So we say that the limit of e to the x minus 1 all over x as x approaches 0 from the right is equal to what, guys? 1. So we can now say that the limit based on this behavior as x approaches 0 of e to the x minus 1 all over x is equal to 1. Okay? So this is how to find limit of a function numerically. Okay? But of course, this is not all the time reliable, no? Because possible that for a function, you will not be able to get the precise or actual behavior of the function as it gets closer and closer to 1. There are functions like that, no? It's hard to predict what the behavior is, okay? But at least from these examples, you will see what is happening in terms of numerical computations compared to graphical. Okay, children? So in graphical, all you have to do is to look at the graph, no? Where the value of the function gets closer and closer based on the graph as your x gets closer and closer to a specific number from the left, from the right, so that you can decide on what the limit of what the limit of the function is as x gets closer and closer to a specific number. Okay, these children? Do you still have questions about this, guys? Guys?
None po, sir.
Okay, so we're going to proceed now to finding limits algebraically. Okay, guys?